On to our next example, and this one we're actually going to start off by just eliminating the parameter. Okay. With a lot of these, when you eliminate the parameter, you can do it just by solving one of the equations for t, substituting it into the other. But a lot of these ones where you see sine and cosine, not all, we'll see an example here in a minute where it's not the case, but a lot of times when you have these trig functions, cosine and sine, you're going to wind up having an ellipse or a circle or maybe even a hyperbola. Okay. Now let's see why. Okay, let's see why. Let's start off by maybe just thinking about what would happen if we were to take x and square it, and take y and square it, and then add these things together. Okay. Well, if we were to do that, well, then this would wind up looking like cosine of 4t. And actually, I'm going to just write it in our conventional notation here, which is cosine squared of 4t. And if you were to square y, you'd get plus sine squared of 4t, right? And this is equal to 1. So what this tells you is that you have x squared plus y squared is equal to 1. We've eliminated the parameter. We just have x's and y's, there's no more t's, right? T is the parameter. Okay, the t's gone. So the question is, well, what is this shape? Okay. Well, this is a circle of radius 1 centered at the origin. Let's go ahead and make that happen. And do our best here to make something that looks like a circle. In fact, this is our unit circle, isn't it? Now, this is just essentially the path that whatever we're describing some motion, and it follows this path, this circle. But the question is, well, where does it start? What direction is it headed? Okay. And do note we have this t equals 0 to 2 pi. Okay. And so let's just maybe start off with t equals 0. There we go. If you were to plug that into our x equation, cosine of 0 is 1, and sine of 0 is 0. So our first point is technically 1 comma 0. That would be right here. Okay. And you could actually even plug in 2 pi, the point where you end, but it also comes out to be 1 comma 0. So this means we start and we end at the same place, which is absolutely fine because this is a circle, right? This thing's actually just going to keep circling over itself if you let t continue to grow. But we're going to stop it again at 2 pi. Okay. Well, if we start and we end here, the question is, well, what direction did we head to get here? I like to take 1/4 of a revolution to help me figure that out. So in other words, if you were to look at the period of each one of these trig functions here, right, the period would be 2 pi over b, which is 4. So this is pi over 2. So that's what I'm actually going to plug in, is actually 1/4 of this. Okay, pi over 2 is just how long it would take to complete one full revolution. Okay. Which means if we went to 2 pi, we've made multiple revolutions. Okay. So let's maybe we'll write this down here at the bottom. It takes pi over 2 units to complete one revolution, which means on the interval from 0 to 2 pi, that means we have 4 revolutions for describing that motion. Because pi over 2 fits into 2 pi 4 times. But again, we wanted to think about a 1/4 revolution. So if you were to cut pi over 2 into a 1/4, so divided by 4, that would be pi over 8. And we want to plug this pi over 8 into each one of these to see where we would end up after a quarter revolution. I'm going to get rid of this. So if you were to plug in pi over 8, that just winds up being cosine of pi over 2, which is 0, and sine of pi over 2, which is 1. So after doing a quarter revolution, we end up here. So that means we must have been heading in this direction. Okay, we're rotating counterclockwise. The last thing I'd like to mention here is that if you're plotting a circle or a ellipse, find the period and take the period and divide it by 4, and that amount of time should be the amount of time it takes to do 1/4 of a revolution. Let's go ahead and try the next example. We have another set of parametric equations here that we want to figure out what its graph looks like. And here's our restricted values for the parameter. And here's our first one where the parameter has changed from t, it is now theta. And so again, we have two strategies so far. One of them is you can solve for the parameter, substitute it into the other equation, and that would be one way of eliminating the parameter. Another one is if you have sines and cosines, sometimes you can just square your x, square your y, and then you know that cosine squared plus sine squared is 1, and you usually wind up with either an ellipse or a circle. This is a case though where that trick is not going to work out for us, and one reason it might not work out for us is the angle is different with these two. And also when we square this is going to be sine squared, cosine squared, and we just would have wanted a cosine squared of 2 theta. That way it matched this when we squared it. So we had sine squared 2 theta plus cosine squared 2 theta. So it's not really going to work out in the same fashion. But I want you to think for a second. Do you see any connection between these two? So we have a trig identity which is going to be particularly useful here. And that is that sine of 2 theta is equal to 2 sine theta cosine theta. All right. Well, then if we were to think about our equation y up there, y equals 4 sine of theta cosine of theta, we could rewrite it as 2 times sine theta. Oop, let me fix that. 2 times 2 sine theta cosine theta. All right, and we know that 2 sine theta cosine theta is just equal to sine of 2 theta. So this is really just y equals 2 times sine of 2 theta. Well, we know that sine of 2 theta is equal to x. So this allows us to say, hey, y is equal to 2x. But we would like to know where we start and where we end. That way we know what direction we're headed. So let's go ahead and start off by filling out this table. So we're going to have theta as our parameter, and then x and y. And so if we were to plug in theta equals minus pi over 4, then we'd end up with sine of minus pi over 2 for our x coordinate. And sine of minus pi over 2 is equal to -1. And let's think about the y value. So the y value is this 4 sine theta cosine theta, or I could actually also use this here. So if we were to plug in theta equals minus pi over 4 down here, that's going to give us 2 times sine And minus pi over 4 times 2, that's minus pi over 2. And so this is going to be equal to 2 times, and sine of minus pi over 2 was minus 1, so negative 2 here. And then we can try this for pi over 4, and similarly we get positive 1, positive 2. So now we know where we start, where we end. Let's go ahead and put these down, and we know what the graph y equals 2x looks like. So we know we have 1, 2 on our graph. And we know that before that we had minus 1 comma minus 2. And let's go ahead and connect these.